Okay. Okay, girls, this is exercise 10.5, sum and product of roots. Okay, we're going to start this exercise with a bit of an investigation. Firstly, we want to solve x squared minus 9x plus 20 equals 0. Anyone factorise that yet? So we've got x minus 4, x minus 5. Therefore, the roots are 4 and 5. What are the sum of those roots? So the sum of roots is 4 plus 5, which is 9. Look at the coefficient of the x. All right? What is the product? But girls, you already know that. Girls, you know when you come to factorize this, don't you say what two numbers multiply to give 20, but add up to give 9? All right? So the product of the roots is 4 times 5, which is 20. But girls, when you come to solve this quadratic equation and you factorize it, you're already saying that. Don't you say what two numbers multiply to give 20 but add up to give negative 9. But the thing is, we've got negative 5 and negative 4, okay? But the thing is, the roots, when we solve this, we don't get negative 5 and negative 4 as our answers. We get 5 and 4, or 4 and 5 as my answers, because we say what minus 4 is 0? Well, it's 4 minus 4 is 0. And what minus 5 is 0? We say 5 minus 5 is 0. So, I'm just going to, have you written that down, girls? Because I need to pause and look at the book. Now, what I'm going to do, what we can do, we can let the roots be alpha and beta. So just watch this. If I let the roots equal alpha and beta, well, I can say the sum of my roots is 4 plus 5, which is 9. In other words, alpha plus beta is 9. And again, if I let my roots equal alpha plus beta, I can say the product of my roots is the same thing as up there. 4 times 5 is 20. So when we talk about our roots, we're going to let the roots be alpha and beta. So we're looking at the sum and product of roots. These 4 and 5 are my alpha and my beta. They're my roots. So these are my roots. So these are my roots up here, 4 and 5. And I'm going to call them alpha and beta. So when I say sum of roots, I want to know what alpha plus beta is. It's 9. When I want my product of roots, let roots equal that. Let roots equal that. When I want product of roots, I'm saying, oh, look at this. Alpha times. Put a times there, please, for this one. Let roots be alpha. So product of roots are alpha times beta. Are you okay with that? 4 times 5 is 20. Now, see that equation up here? X squared minus 9x plus 20. Can't I say that? I'm going to rewrite that now. Can't I say that's really x squared minus the sum of roots? Aren't my sum of roots 9? Yeah. So it's x squared minus sum of roots times x plus product of roots. So, all right, now I need to make some room. So when I look at what I've just done, and I've called the sum of my roots alpha plus beta, so here I've got alpha plus beta, is 9. Here I've got alpha times beta, or alpha beta is 20. Okay? They're the sum of my roots. They're the product of my roots. Got the idea? I'm now coming up to the original equation. I'm replacing that 9 with sum of roots, and I'm replacing that 20 with product of roots. Isn't it really x squared minus, now how do I write sum of roots? Alpha plus beta times x plus product of roots is alpha times beta. Now, just copy that down. Okay, I know what I'm doing. I'll just focus. All right, but we know that the general form of a quadratic formula, and we've been doing it all week, is ax squared plus bx plus c equals 0. Now, I'm just going to compare 1 and 2, but they're not quite the same. How am I going to make this? I don't want an ax squared. I want to get rid of this a. So what I'm going to do is I'm going to divide through each term by a, because I want it to look like x squared minus something plus something. So I'm going to divide this whole equation here, each term by a. What do I get? X squared plus bx over a plus c over a equals 0. Now, I'm going to call this one equation 2. So I'm going to go, but the general form of my quadratic is this. Okay? But I want the x squareds to look the same. So this is what I'm doing now. I'm comparing this box here, equation 1, with equation 2. So now I'm going to come up with 2 little conclusions. And for those of you that have done sum and product of roots before, you'll know what I'm about to write. Comparing equation, let's compare. Comparing the coefficients of equation 1 and equation 2. What can you say that, can't we say that the minus alpha plus beta equals what? The thing in front of the x here has to equal the thing in front of the x. Yeah, it's b on a, but we never see it written like that. Let me take the negative to the other side. So what I've really got is that alpha plus beta, I'm going to multiply both sides by -1 or something, or take the negative to the other side, all right? Equals minus b on a. That is the first rule, that the sum of your roots will be minus b on a. And over here, I want to look at my product of roots. Just one sec. Compare the coefficient of the x's. So negative bracket alpha plus beta equals b on a. You can either divide both sides by -1 or multiply both sides by -1 here, and we get that alpha plus beta is negative b on a. In other words, alpha plus beta is the sum of my roots is minus b on a. Okay, sum of roots of any quadratic is minus b on a. Now, over here, I'm going to look at the constant terms. So comparing the constant terms, what can I say? Look at the constant term there and this one. What can I say? Alpha times beta equals c on a. Now, alpha, so that's our next equation. So in other words, the product of roots is equal to c over a. Okay, I'll move this down. So those things in the boxes, I need you to know this, number 1, that parabolas, that quadratics can be written like that. Also, you should know the general form of a quadratic, and you should know this other starred form of a quadratic. So if you know the general form of a quadratic, and you divide it all through by a, each term by a, and if you divide the 0 by a, you get 0. And you should also know this too, up here, that your quadratic is x squared minus, but it's this one, x squared minus the sum of roots x plus product of roots equals 0. Or if you know this one, ax squared plus bx plus c is 0, we know you all know that. If you divide that one by a, you get this. But look, the main thing is that you know that the sum of roots, or alpha plus beta, is minus b on a, and that the product of your roots is alpha times beta is c on a. Got all that? Can I pause? This stuff up here. Now what I'm going to do is, let's say, sorry we can't see that. So let's say that the roots of an equation are alpha and beta. You know, if your roots of your equation are, say, alpha and beta, now look what happened up here. The roots of my equation, just look up here. The roots of this first equation up here are 4 and 5. Where did 4 and 5 come from? X minus 4, x minus 5. Got that? You all need to be watching, otherwise you're going to have no idea what I'm talking about. So if your roots are 4 and 5, they came from x minus 4, x minus 5. So let's say the roots of my equation are alpha and beta. Where did they come from? The roots of my equation before were 4 and 5, so they came from x minus 4 bracket x minus 5. So if my roots are alpha and beta, they came from, therefore my equation is x minus alpha bracket x minus beta. Now what I'm going to do, I'm going to expand that. What do you get? X squared. So if the roots of my equation are alpha and beta, then my equation is x minus alpha, x minus beta. Actually, it could be a bracket x minus alpha, x minus beta, but I'll just leave it at the moment. So expanding this, I get x squared, come on, FOIL method, minus beta x minus alpha x,
plus alpha beta.
Good, plus alpha beta equals 0. Any like terms in there that I can factorize? X squared minus x bracket, I've taken out a minus x, what's left? Beta plus alpha. We're going to make this look nicer in a minute. So I've got x squared, the x's are like terms and so is the minus, so I'm going to pull out minus x and then I've got beta plus alpha. Now we never put the x in front of its coefficient, so let me put the coefficient in front, and would you normally write, sorry that's an alpha, would you normally write the beta plus alpha, or does alpha plus beta sound better? So let's go minus alpha plus beta x. We've seen this before, haven't we? You did see it before. So girls, I'll just fix that up. That's what we had before. So, okay, so I've got minus x is a common factor there, beta plus alpha. Look, minus beta x minus alpha x. All right, so I'm going to put the coefficient of the x in front of the x. So it's minus alpha plus beta in brackets x plus alpha beta. Okay, so girls, again, okay, girls, so can we see that? The general form of a quadratic is x squared minus the sum of the roots times x plus the product of the roots. Okay? No, this is the theory. We need to be really familiar with all these forms. So you need to know this form. You need to know the ax squared plus bx plus c form. You need to know that the most important thing, sum of roots is minus b on a, product of roots is c on a, and that an equation can be written like this. So this is now the general quadratic equation, can now be written in terms of not coefficients a, b, and c. I mean, we can write it as ax squared plus bx plus c equals 0. So you can write something as ax squared plus bx plus c equals 0. But now we know we can also write it as, dividing through by a, x squared plus b on a x plus c on a equals 0 on a, which is 0. So now you've got to be familiar with the ax squared plus bx plus c is 0. If you divide that all by a, you get this second one here. But you also need to be familiar with this one. Now, it's almost the same as that, but you'll remember it because you know that sum of roots is minus b on a. And this one's got a plus b on a. So this has got to be minus sum of roots. So that sum of roots equals minus b on a. See how I've got plus b on a? I've got to make this one up here minus now, because sum of roots is minus b on a. All right? Product of roots is alpha times beta is positive c on a. That's all okay. So the alpha times beta is equal to the c on a, but I've got to have a change sign here. Okay? All right, now we're going to do some examples. We're going to do some examples now. So the first one is exercise 10.5, question 1b. And that question is to find alpha plus beta and alpha times beta if alpha and beta are the roots of that equation, which is 2x squared minus 3x minus 6 equals 0. So let's write down the definition of alpha plus beta. Alpha plus beta is sum of roots, which is minus b on a, which happens to be minus negative 3 over 2, which equals 3 over 2. Product of roots, alpha times beta, is formula c on a, which happens to be negative 6 over 2, which is negative 3. Now, that's all they wanted you to do, but let's go one step further. Do you think you can write the quadratic equation? Now, this is extra. Isn't the quadratic equation x squared minus alpha plus beta x plus alpha beta is 0? So an extra question here is to write the quadratic equation. Oh, it's there. What's wrong with me? But let's have a look. X squared minus, what's alpha plus beta? 3 on 2x plus, what's alpha times beta? Now notice that's not the same as up there. Right, because I've got to get rid of this 2. So if I multiply through, so times through by 2, you'll see that you get 2x squared minus 3x plus minus 3 means minus 3 minus 6. See how I get the original equation? All right. And, okay, that'll do for now. All right. So, all right. But you're not supposed to do that. I'm just showing you that format. Now, let me tell you, everyone forgets this format, x squared minus alpha plus beta x plus alpha beta. But if you remember it as when you look at this, you say, what two numbers? I know this is a 2x squared, but if the 2 wasn't there, don't you say what two numbers multiply to give that? So this last one's always product of roots, and what two numbers add up to give that. But because we know sum of roots is minus b on a, you've got to put a minus in front of this one. All right? Don't worry about that yet. So let's look at this question here. Now, if alpha and beta are the roots of the quadratic equation, find the value of alpha plus beta. Now, alpha and beta are the roots of this quadratic equation, find the value of alpha plus beta, alpha times beta. Remember, that's the sum of the roots, product of the roots. Then we're going to do these. Now, do you think you could solve that? Do you think you can factorize this? What two numbers multiply to give negative 6, but add up to give negative 3? What have you got? You've got negative 6 times 1. They will never add up. Negative 1 times 6. Alpha and beta are the roots of the quadratic equation, find the value of. Now, look, we cannot factorize this. Look, minus 3 and positive 2 can't give minus 3x. Positive 3 and negative 2 can't give minus 3x. There's no way we can factorize it. Alpha plus beta, what is it, girls? Minus b on a, which is negative 3 over 1, which is 3 over 1, which is 3. Alpha times beta is c on a, which is negative 6 on 1, which is negative 6. Now, I can't work that out. There's no formula for that, but there are formulas for alpha plus beta and alpha times beta. You've got two fractions with different denominators. It makes sense to make a common denominator. So, what do you multiply? What do you end up with? This one needs to be multiplied by beta on beta. This one needs to be multiplied by alpha on alpha, or we do the little butterfly. That times that times that, over that times that. So don't we get beta plus alpha over alpha beta? You okay with this, girls? That times that times that, over that times that. Well, what's alpha plus beta or beta plus alpha? 3 over alpha times beta, negative 6. So it's negative a half. Now, alpha squared plus beta squared, there is no formula for alpha squared plus beta squared, but where do you think alpha squared plus beta squared may come from? Yeah, a perfect square. So it comes from a perfect square. So I'm just going to leave that at the moment. Let's investigate the formula for a perfect square down here. Alpha plus beta all squared equals what? Alpha squared plus 2 alpha beta plus beta squared. So if you want just alpha squared plus beta squared, what do I need to take over alpha beta? So I just want to keep these here. Let me take the minus 2 alpha beta over there. So therefore, alpha squared plus beta squared is alpha plus beta all squared, because you know you square the alpha and you square the beta, but you're going to end up with plus 2 alpha beta. Well, I want to undo that 2 alpha beta. See, because alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta. Do we get that? Now, Do you understand that we're trying to make this look, it needs to be in terms of only alpha plus beta and alpha times beta, because we've only got formulas for alpha plus beta and alpha times beta. There are no other formulas. You only have two formulas. Sum of roots, alpha plus beta is minus b on a. Product of roots, alpha times beta is c on a. So therefore, what does alpha plus beta squared equal? So what's alpha plus beta? 3 from part A. Alpha plus beta is 3 squared minus 2 times negative 6. So I've got 3 squared is 9 plus 12, which is 21. So you need to, if you see alpha squared plus beta squared, it comes from the expansion of the perfect square. The expansion gives you alpha squared plus beta squared plus 2 alpha beta. I don't want the 2 alpha beta, so I take away the 2 alpha beta straight away. Okay? All right, and then you substitute in your alpha plus beta here, and you substitute your alpha beta there. Okay? Doing this example here, but we're just looking at the method in the textbook. And the method in the textbook says find the quadratic equation that has roots 6 and negative 1. What they're doing, if their roots, they're letting alpha be 6 and beta be negative 1, and they're writing that this is the general formula of a quadratic, x squared minus alpha plus beta x plus alpha beta. Then they're working out what alpha plus beta is, and it's 6 plus negative 1, which is 5. They're working out what alpha times beta is. 6 times negative 1 is negative 6, and then they're substituting it in there. I think that's harder, okay? The other way of doing it is method B. You start off with your equation can be written as x minus alpha, x minus beta. Because, you know, if your answers, remember 6 and negative 1 are your answers, you say, where did 6 and negative 1 come from? What was the second last line of working once I factorized? And that 6 must have come from x minus 6, and that negative 1 came from x plus 1 is 0. Please, if you're going to use this method, do not put x plus 6, x minus 1. See, x, if 6 and 1 and negative 1 are the roots, what I'll do, I'll just, wait a sec. Just be careful here. The 6 came from x minus 6 and the negative 1 came from x plus 1. All right? So this is method 2, where you're doing it like this. And then you expand, okay, and then you combine like terms. All right? We're just going to look at this other example here. You can choose to write them at home if you want. We're just looking at them, then I'm going to do 2 questions from the exercise. This is another method where, again, you're working out the sum of roots, because they've given you the roots here, that your roots are 3 plus root 2, 3 minus root 2. Method 1 is using the formula. Sum of roots is just adding those two together. You get 6. Product of roots, multiplying those. Aren't they difference of 2 squares? A plus B, A minus B. And then substituting it into that formula. Method 2 is, if these are my answers, what factorization did they come from? Now this is looking pretty complicated. So you may choose, I think you should choose method 1 for this other type. Look, when we do these 2 examples now, we're going to do both methods, all right? So I'm going to do both methods with 2 questions from the textbook. But just be really careful if you're going to use this method too. When you've got surds, it can get a little bit messy, all right? Having looked at those, if you get a nice simple one like this, let's just say, where did this come from? So find the quadratic equation whose roots are negative 3 and 7. Where did that come from? X plus 3, x minus 7 equals 0. Expanding that, x squared minus 7x plus 3x minus 21 equals 0. In other words, it came from x squared minus 4x minus 21 equals 0. Okay, I'm not going to do the other method. But this one, look, I'm going to do both methods for this one. So if that's one of my answers, you've got to be really careful with this one. Notice the positive one has the x minus and the negative one here has the plus. We can use, do you want to do both methods or just the, let's just do the alpha plus beta method. So if they're my roots, alpha is, all right, we're looking at this question. Find the quadratic, 3e, find the quadratic equation whose roots are 1 plus 2 root 7 and 1 minus 2 root 7. Because it's going to be a little bit complicated to do the x minus, we can try it in a minute. I'm going to use this other method. So my roots are, my first root alpha is 1 plus 2 root 7. My second root beta is 1 minus 2 root 7. So sum of my roots is alpha plus beta. So it's alpha plus beta. What cancels out? The 2 root 7. So it's just 1 plus 1 is 2. And alpha times beta is 1 plus 2 root 7 times 1 minus 2 root 7. And this is in the format of a plus b, a minus b. Doesn't that equal a squared minus b squared? It's the difference of 2 squareds, so it's equal to 1 squared minus 2 root 7 squared, which is 1 minus 2 root 7 squared means square the 2 and you get 4. Root 7 squared is 7, so it's 4 times 7 is 28. So therefore it's minus 28. Therefore, isn't the equation x squared minus alpha plus beta x plus alpha times beta? Put the negative there. So it's x squared minus, what's alpha plus beta? 2x plus,
minus 27.
yeah, so plus negative 27 or minus 27 equals 0. Okay, so that's that equation. The other way was to go and do it like this. It's x minus this one and x minus, oh, but they're both positive. They're both positive, so it is x minus, and then expand it all, but that gets a bit messy. All right? Now, I'll be doing another video tonight with the rest of my examples, and I'll be sending you homework via that video and email. Okay?